Hi, good afternoon, everyone. Let's start my presentation. Before starting of my presentation, I would like to thank the organizing committee of SIPS 2022 and this symposium organizer, Professor Inusa and Professor Yoshikawa. So I come from Shibaura Institute of Technology, Japan. That is located in Tokyo, metropolitan of Tokyo and Saitama Prefecture. Okay, so today I would like to talk about the biological effect of Twendee X on vitamin E deficient mice. So this slide shows the information about the aging process. So x-axis shows the maximum lifespan. So time axis is different, but every species cannot prevent aging process. So what is the mechanism of aging? So can we manipulate aging process? The answer is yes. So aging process is divided two major topics. So one is pathological aging and the second is physiological aging. In the case of my research, I will say many times aging, but that means is pathological aging. So this slide shows a negative correlation between the maximum lifespan and reactive oxygen species, that is superoxide production. So x-axis shows the maximum lifespan and y-axis shows the superoxide production. So as you can see, mice, rat, and hamster, these rodent model very short lifespan, and they are very high superoxide production and high metabolic rate. This photograph is my previous picture, so I'm also getting old. Okay, so reactive oxygen species are closely related to the maximum lifespan. Okay, this slide shows the result of the effect of calorie restriction research. So as you can see, so x-axis shows the maximum lifespan and y-axis shows the result of the rate of survival. So blue line is the 20% calorie restriction. The red line shows the 40% calorie restriction. So as you can see, DBA mice and C57 black 6 mouse, and male and female mice show the lifespan extension in calorie restriction model. So he's one of famous calorie restriction research. So his name is Rafael De Cabo. So he was my mentor in United States about 7 years ago. So this is extra information about lifespan extension. Resveratrol and metformin. These drugs also induced lifespan extension. These effects are very similar to the calorie restriction research. So this is a mechanism of calorie restriction work. So there are a lot of factors that affect lifespan extension in the calorie restriction research. So as you can see, oxidative stress and metabolic rate are deeply related to the effect of lifespan extension in the calorie restriction research. So metabolic rate and oxidative stress accelerate aging. So what is the relationship between oxidative stress and cognitive function? So this slide shows a result of our previous data. So we made two different kinds of vitamin E deficient mice. So one is a short-term vitamin E deficient mice, and second is a long-term vitamin E deficient mice. So we fed vitamin E free diet. So the left side shows the result of the Morris water maze test. So x-axis shows the trial day, and y-axis shows the time to goal. So that is the escape time. So as you can see, every group gradually decreases time to goal. However, long-term vitamin E deficient mice significantly lower the time to goal compared to the age-matched control mice. Okay. So running ability decreased in the long-term vitamin E deficient mice. So this slide shows the result of a video image of the Morris water maze test. So, yeah, as you can see, the left side shows the result of a normal mice. On the other hand, the right side shows the same aged vitamin E deficient mice. The months of age and the trial number are same. So as you can see, the left side, the normal mice, it could rapidly find the escape platform. However, long-term vitamin E deficient mice could not find escape platform. The learning rate is significantly different between two groups. But the difference of two groups was only diet. So one is a normal diet, and the second one is a vitamin E-free diet. So we checked about the swimming distance and the swimming speed, but there are no significant difference between two groups. After finishing cognitive trial, we dissected these animals and divided different parts of the brain and checked about the brain oxidation level. So we found in the case of long-term vitamin deficient mice, significantly increased lipid hydroperoxide compared to the normal mice. And we found the apoptotic cell in the hippocampal CA1 region. So this slide shows the result of brain vitamin E level. So after dissection, we separate three different kinds of brain, cortex, cerebellum, and hippocampus. So white bar shows the result of a normal mice brain. So we measured vitamin E level by HPLC with ECD detection system. So we could find similar level of alpha tocopherol. On the other hand, a black bar shows the result of a vitamin E deficient mice. So as you can see, a short-term vitamin E deficient mice, a very small amount of alpha tocopherol we could get by the measurement of HPLC system. On the other hand, long-term vitamin E deficient mice, we could not find alpha tocopherol at every brain lesion. Okay, so long-term vitamin E deficient model is very important. Yeah, accelerate brain aging. So this is a similar experimental result of our previous study. So we measured brain thiobarbituric acid reactive substances level. So as you can see, the 3-month-old animal, there was no significant difference between two groups, as a normal mice and vitamin E deficient mice. On the other hand, the 6 months of age, the long-term vitamin E deficient mice, they significantly increased brain lipid oxidation level, okay? So these results indicate that the long-term vitamin E deficiency is a good model of increased oxidative stress. So this is a very interesting result of our previous data. So this is immunohistochemical analysis. So as you can see, AD mice is a 5XFAD mouse is one kind of transgenic mouse of Alzheimer's disease model. So we stained about beta amyloid deposit. So you can see the brown deposit. Okay, so that is accumulation of a beta amyloid deposit. So we stained together using human Alzheimer's disease brain. So as you can see, human Alzheimer's disease brain, we could found accumulation of beta amyloid analysis. On the other hand, normal aged mice and long-term vitamin E deficient mice, we also detect the immunopositive reaction in hippocampus GA1 region. So that is normal aged mice, and the second one is a long-term vitamin deficient mice. But anti-beta amyloid antibody react in hippocampus GA1 region, okay? So upper panel of the middle photograph of upper panel show the result of 10 days after hyperoxia, we exposed to a high concentration of oxygen to the mice, and 10 days later, we dissected the animal and we were making a slice. So that model, we also detected the immunopositive region. So oxidative stress may be a starter of beta amyloid accumulation. So to prevent brain oxidation and loss-induced aging, we need to take antioxidants such as vitamin E and C and other substances. The intake of mixed antioxidant to increase this effect, so such as vitamin C and E and multivitamin and others. However, the optimal combination is unknown. So my study is tried to the effect of multi-supplement on long-term vitamin deficient mice. So we use Twendee X. So Twendee X is developed by Professor Haruhiko Inufusa in 2005. So Twendee X is a multi-antioxidant complex containing 8 substances like this. So several kinds of evidence are demonstrated that treatment with Twendee X is a very good effect for our health. So in the case of my study, we fed this volume to the experimental animal. Okay, this is a methodology of animal conditions. So we prepared 1 month old C57 black 6 mouse, and we fed a vitamin D deficient diet for 5 months. After that, we divided 2 groups. So one is normal filtered water, and the second one is a Twendee X for 1 month. So after that, we studied analysis of cognitive function and biochemical analysis. So this slide shows a result of body weight and food and water intake volume in our animal models. So green zone show the result of a final 1 month period. The final 1 month is divided 2 groups. So one is a normal filtered water, and the second one is a Twendee X-treated group. Okay. So as you can see, body weight and food and water intake volume were, it was not significant difference. So this slide shows explanation about the Morris-Watermaid test. So there are a lot of methods in cognitive performance, but I want to explain about the case of my laboratory method on Morris-Watermaid test. So in the case of my laboratory, we performed 4 times per trial, 4 times per day, and continued for 5 continuous days. We prayed same time, and total number of trials was to 20 times per mouse. Yeah, this is a previous our experimental video image of Morris-Watermaid test. So the left side shows the first trial day, and the right side shows the final trial days. The animal was same rat. So first trial days, it could not find escape platform, but final trial day, this animal could find escape platform very quickly. So Morris-Watermaid test is a good tool for the judgment of mouse and rat cognitions. Okay, so this is a result of Twendee X research. So blue line shows the result of untreated vitamin E deficient mice, and red line shows the result of Twendee X treated vitamin E deficient mice. So as you can see, goal time, treatment with Twendee X was significantly faster than untreated group. This figure shows the result of the ratio of platform staying time. Every day, treatment with Twendee X is increased at the ratio of platform staying time compared to the untreated group. And we measured swimming speed at the final trial day. So this is very interesting result because treatment with Twendee X, swimming time was significantly lower than untreated group, okay? Not faster. So this is a question, why did Twendee X-treated group faster goal time, but slow swim speed? This is my hypothesis. So generally, mice do not like water, so it is possible that Twendee X-treated vitamin deficient group may have been calmer than the untreated mice group, and Twendee X may reduce anxious behavior. So next study, we checked about the coordination ability using a rotor rod test. So this is an apparatus condition. Rotor rod speed gradually faster until 2 minutes, okay? So this is a result of the time to fall. The score of time to fall in Twendee X-treated mice was significantly higher than untreated group. Basically, the result of the rotor rod test is depend on the body weight. So as you can see, we analyze the relationship between body weight and the score of time to fall. So as you can see, red circle show the very good time compared to the untreated vitamin deficient mice in the similar weight volume. So this is a result of a neurotrophic factor expression. So after finishing cognitive performance, we dissected these animals and we divided cortex and hippocampus, and we measured BDNF and NGF and their receptor by Western blot analysis. So as you can see, in the cortex region, treatment with Twendee X, the level of BDNF and NGF was significantly increased compared to the untreated group. So next one, we measured some serum indexes. So before starting of this study, we expected the changes in the cholesterol level and the triglyceride level. But these scores did not change after treatment with Twendee X. It's just only total protein and iron level was significantly decreased in Twendee X treated mice compared to the untreated group. So this is a summary of my expression, my study. So long-term vitamin deficient mice are a good model for oxidative stress induced. And treatment with Twendee X improved cognition. One possible mechanism of cognitive improvement is to BDNF expression in the cortex region. So, Twendee X, a mixed supplement, has an excellent effect for improving oxidative damage-related disease. So these data are accepted JCBN journal. So that journal is the official journal of the Society for the Free Radical Research Japan. It just accepted last month. So this is a final slide on my presentation. This is acknowledgement. Very thanks to the Professor Yoshikawa and Professor Inufusa and other laboratory members. Thank you very much for your kind attention.